Hello everybody, it's Yuri Goman and today I will teach you to draw UML state machine diagrams. We will start with explaining what state diagrams are, what you need them for, and then create an example of our own. UML state machine, or just a state diagram, is a behavioral diagram. It shows the different state of an object or a system, how they move from one state to another, and what triggers those changes. This diagram is helpful for many stakeholders. For example, developers would see a list of entity statuses and what makes them change. Designers, on the other hand, could get some ideas too, assuming that each state is an end screen and triggers are users' actions, while the whole diagram is a user flow within the system. To create a diagram, we first need to consider a topic. I suggest we create a state machine diagram for an ATM. Something we all use often. The first step to building a diagram for this process is considering all possible states. What could be the state for the ATM in our case? Let's drag a bunch of simple states out there. When we approach the ATM, it's obviously idle and waiting. Then we insert our card and it becomes operational while we use it. Sometimes when we approach the ATM, it is out of service or even off, which is a bummer, of course. We could also assume that at some point each ATM needs to perform self-diagnostics and send information to the server, or we could even see the technician working on fixing something, meaning there should be some kind of maintenance mode. Cool, now we have all the major states we could think of and now we can start charting transitions, but before that we need to add an initial pseudostate. In the beginning there was nothing, meaning the ATM was off. Then someone, probably a technician, switched it on. It is wise to perform self-diagnostics on the startup, so let's put a transition here as well. If everything goes right, the ATM should get into an idle state and wait for the customer. If not, it would probably go straight to out of service state. When the customer approaches the ATM, they insert their card and considering the ATM is working, they make it operational. Looks good, but at this point I start seeing that the operational state is too primitive and doesn't show a lot of stuff that the user or ATM does. So let's throw some details into that. For that, we can use the composite state. Basically, we expand the state and add a bunch of substates inside where we can add all the screens the user goes through. First is customer authentication, which includes entering your PIN code and verifying the card by ATM. What you can do here is to combine them into a single state, not to bother too much, or create them separately, or even develop more states to show more different steps. I feel kind of lazy today, but intelligent lazy. What I will do is to call it customer authentication and mark it as a hidden decomposition composite state by adding this symbol, assuming that there are more steps inside, but I will work them out later. Looking good. Next, what we do is to choose an operation. We can have many different screens here, but it's not that important to mark them all, so let's make another composite state. Now, when we choose an operation, which is usually getting some money, we can start performing our transaction, which is also a complex process. So for the sake of your time, let's not dive too deep into it. Adding those three steps shows how we use the system as customers. So now we can add a final pseudostate and roll with it. If everything goes right during the operation, the system should return to the idle state and wait for another customer. But what if there is a problem? For example, we can enter the wrong amount and want to change it, or we entitled to change our mind completely because now for some reason we don't need any money. In this case, we can cancel everything and the system returns to the idle state using an exit point pseudostate because it's an exception path. What also could happen is a system failure, like money chewed within the ATM. In this state, the system cancels the operation but cannot return to idle due to an error. In this case, the system should go to the out-of-service state through another exit pseudostate. When such an unfortunate thing happens, someone should call the technician and put the system into the maintenance mode until they fix it. Sometimes ATMs cannot be fixed at all, it's a bummer, and the maintenance fails. In this case, the system might be sent back to out of order until fixed or switched off to be removed completely. To finish the list of possible transitions for this diagram, we should also mention that the system might require some kind of planned maintenance. Thus, we should add another transition from idle to maintenance. Or we might need to move completely functioning ATM to another location, so we need to switch it off adding another transition to our diagram. And this, my friends, is how you build state machine diagrams. Thanks for watching this tutorial. I hope it was helpful. As you know, there are more UML diagrams you can use as a business analyst for different purposes. So if you want to learn more, subscribe to this channel to catch future videos, and then you may check this tutorial out here.